So welcome to this webinar on Agile Data Warehousing with Snowflake that we are running together jointly with Snowflake and Big Data Solutions. My name is Sakusel, I'm the Managing Director for Big Data Solutions, and I have my colleagues next to me, Ossi Manninen and Tapani Desi. Two slides about us, Big Data Solutions. So we are a cloud analytics company based in Helsinki. We're focusing on cloud analytics and planning analytics on cloud. We are partnering with Snowflake, AWS, Exasol, Burst, and Anaplan, and basically running consulting, training services, and managed services on AWS environments. Of the introduction, and before I will hand over to Anthony. So Anthony, you're now unmuted and I will give you the control over the slides.
Thank you, Saku.
So you should have the control now.
Okay. Yep. Okay, thank you. Okay, my name's Anthony Schneider. So I work at Snowflake. I've worked in the data warehousing space for probably the last 10 years. So I'm a long-time user of Snowflake on the client side. So we used it to implement our cloud transformation strategy. I've now come across to Snowflake to work with partners like Big Data Solutions and make sure they leverage all the capabilities that Snowflake has to offer. If I just jump to the next slide. Okay, so I'll just jump into some of the challenges that are probably very common to a lot of you. So what companies need from their database platform. So they definitely need to support concurrency. One of the biggest challenges in the maturity in a database is shown by its ability to handle large amounts of concurrency. That is hundreds of applications, lots of users fighting for the same resources in that platform. Scaling is also a very difficult thing to achieve in traditional platforms. So we need to be able to scale elastically, fluidly, both from a compute and from a storage perspective. Resiliency, also a large challenge. It can be quite expensive. Companies are needing high availability so that in the event of failure, they can cross over to another a backup platform. Security, you will have seen this. A lot of customers are struggling with the security in the cloud. So Snowflake's been built to make sure we overcome any of those concerns around security. So we have financial clients, retail clients, health clients. So security is a very important aspect of the platform and a challenge that that everyone comes across in their implementations. So I just want to talk briefly about one of our clients in Capital One and some of those challenges that they had. So we'll talk a bit about the concurrency and the Monday morning challenge, as I like to refer to it, but it's very hard they were having a lot of troubles catering for peak demand on that database. So a Monday morning, a lot of users were coming in and running reports. Another use case is Deliveroo, a food delivery service. On the weekend was when all their shopping activity happened. Monday morning, thousands of users would hit their Tableau reports or their BI reports, and that would slow the database down. So that was one of their main challenges. They had a data scientist arm of the business, so they really needed to be able to scale easily and automatically. So data scientists are all about proving hypotheses. That can be with large amounts of data that they quickly need to ingest, and then some really heavy computation, so really heavy amounts of compute that they need instantly. And it was typically taking them weeks or months to scale the size of their disk or scale the compute they needed to perform those hypotheses. Resiliency, being a bank, always very important. So they needed 100% uptime. They needed to ensure that data was protected and data was not lost. So they were struggling to implement that in the existing platforms. And then, of course, security. Getting security out of the box from some DBMSs is quite difficult. Obviously, when we talk big data technologies, that can be an even more degree of difficulty. So they were having a lot of trouble implementing security in their existing platforms. It was time consuming, and there was a lot of activities that they had to undertake to make that work. So they decided that that couldn't be fixed with traditional architecture. So on the left, we have the traditional architectures that you've probably used and known throughout your history in the business. So the two most common, of course, are your shared disk architecture. So if you think MySQL, Postgres, a lot of the OLTP operational databases operate within that kind of platform. The MPP platforms that exist, they worked under a shared nothing architecture. So that was decentralized, local storage, and chaining those clusters together. So, chaining those nodes together. So as you can imagine, a lot of data movement between the nodes, but it was a shared nothing architecture that allowed them to scale for the large data volumes that were now being analyzed. So Snowflake presents itself as different to those two architectures. We have what we refer to as a multi-cluster shared data architecture, and we'll dive into that in more detail. But what it means is we have a centralized scale-out storage component of the platform, and then we have multiple but independent compute clusters to do that processing. So very independent, the storage from the compute and the processing part of the architecture. So how do we do it? How do we achieve that those requirements around instant and unlimited scalability? So this is what we refer to as the Snowflake star that gives you a good introduction to the architecture. The database is a typical database as you would understand it in the form of tables and schemas. So that is where your data resides, in tables with all the appropriate roles and permissions. So stored once in the database. But you then have this concept of virtual warehouse. Now, I like to think of virtual warehouse as more of a marketing name for the technical people in the room. That is the compute. The virtual warehouse is the compute. So as you can see, you can spin up as many of these compute clusters as you need, and you can actually add independent compute or virtual warehouses depending on the use cases and depending on the user groups. So as you can see there, they've got a dedicated compute cluster for the ETL and the data loading. They have also a dedicated compute cluster for the data scientists down there. So that ensures that there's no contention of resources between those two business departments or those two use cases. Obviously, the sizes of those can differ as well. So very important. So data isn't moving from the database to the virtual warehouse. You're not storing data in multiple places. Data is stored once in the database, and all those virtual groups, virtual warehouses are accessing that same data. So you can scale each virtual warehouse or compute cluster independently to provide that additional compute power. So the ETL load might be going fine on its small virtual warehouse compute cluster, but the data scientists are struggling. You can, in real time, add more compute to that data scientist cluster and allow them to do their heavy lifting completely independent of the other groups in the organization. The other thing that we'll talk about in a bit more detail later is the concurrent workloads and how multi-cluster warehouses solve that. So that Monday morning challenge, so your BI users on the right there, Monday morning, 1,000 users hit the database. Snowflake automatically under the hoods can be orchestrated to scale out automatically as more users hit that same data, that database. So that's what we call multi-cluster, and it will spin up to as many as the client deems that they want to make sure that you handle that computational load that's on the system. And we'll talk a bit more about elasticity. Snowflake will also spin back down when those queries shrink back down to less of a load. That has dramatic implications and allows to organizations to save a lot of their costs. So if I dive into the Snowflake architecture in a bit more detail, it really is composed of three core components that we talked about briefly before. So we have storage. The storage is based on, in AWS's case, S3. That is Snowflake's proprietary format. So that's the core tables, schemas, and the data that resides. You then have your compute cluster, which we just talked about, the virtual warehouses. So under the hood in Amazon, these are EC2 instances, and they do all the computations. So they're the ones that are grabbing the data from the database storage and performing those computations. So they're really doing the grunt work, the heavy lifting. The third layer that we have up the top there is our service layer. This is really the brain of Snowflake. So this determines what queries are running at any given time. This implements your security or your roles and your privileges. And we are an ACID compliant database, so this handles all the transactions to determine which tables are being written to, which tables are being read from. It also helps with the optimization for any given suite SQL query that's hitting the database. So that metadata is kept separate from the storage and compute, making sure that there's zero contention. So obviously, to see what queries are running on the database, you would, our UI queries that metadata layer. So regardless of the queries that are hitting the centralized layer, you'll always have access to that information within our service layer. So these are the three main components. You have that storage, that separation of compute, and you have the brains that exist within that service layer. So just touching on scale, again, back to the Monday morning challenge. If we look at this graph as a typical use case of usage throughout a Monday, you'll notice there's a peak in the morning as everyone comes in to run their queries. Obviously, that will dip come lunchtime as everyone heads out to lunch. You'll then, after the requirements are coming in from senior management, you'll have that uptake of users running queries against the database. So you've got some peaks and troughs in demand for SQL queries that are hitting the database. What you'll find with your traditional databases, your on-premise solutions like Vertica and other DBMS systems, is you generally have to build a cluster, build out the amount of nodes to suit peak demand. So you determine, or how many users am I going to have at that peak period of time? I'm going to put out a cluster that supports that. So as you can see in the middle of the Monday there, that large cluster is sitting there very underutilized. And obviously scaling up that cluster can be a slow and difficult process. So Snowflake, though, has overcome that challenge. We obviously scale throughout the day depending on that demand. So Monday morning, as soon as those 100 users hit the Snowflake database, we can scale up to meet that challenge. Obviously, then as they go to lunch, it can automatically scale back down to 1 or 0 instances if need be. So you're really limiting what you spend by only paying for the compute that you need. So that eliminates that concept of overbuying, building a cluster that's too big that isn't being fully utilized. So you only pay for what you are using. So if there is 0 people on the database, 0 people running queries, then you're not paying any money. So tremendous cost savings, as you can imagine, over weekends and low periods of activity. It can then automatically scale up using multi-clusters when that demand hits those peak capacities. So that can happen transparently and automatically. So no DBA needs to play a role in that. There'll be the initial setup, and then it will cater for those peaks and troughs in demand. So onto resilience and business continuity. So as I mentioned, the underlying storage part of Snowflake is built on S3. So AWS has done great work with their S3 platform, and that obviously has the resiliency across 3 Amazon regions. So you have full confidence that your data is resilient and safe from any problems in any of the availability zones. Virtual warehouses too, they do spin up across those 3 availability zones, and queries will dynamically move and spread the load across those. So in the occurrence of an availability zone going down, you wouldn't have to worry. The remaining availability zone virtual warehouses will pick up the load. We also have replication of that service layer across all 3 availability zones. Again, you can have full confidence that all the metadata to support Snowflake and support the data platform will be operational 100% of the time. Now coming on to security. So we've put a lot of effort in Snowflake because we understood security was something that scared a lot of our customers. So we wanted to make sure that we were a fully secure and compliant database. Authentication, we do support multi-factor authentication. So using mobile devices to multi-authenticate. We do have federated authentication available. So moving existing clients in and tying into their existing Active Directory installations or other authentication platforms is possible. Access control will be what you're used to in any standard DBMS. We have roles, users, and you can provide privileges at any level. So at a schema, table, database level, just to ensure that the users are only accessing the appropriate areas of the database. Data encryption, all encryption in Snowflake, all data in Snowflake is encrypted. So we don't sort of have an unencrypted version. We decided that we could still deliver the performance that Snowflake delivers, encrypting 100% of data out of the box. So we have a couple of ranges of how you can do that. Obviously, it is encrypted out of the box. Snowflake can own those keys. We can have a shared key arrangement with a customer where we both have a set, or some customers decide to take ownership of those encryption keys themselves. But that's all managed automatically. So as soon as you're loading data into Snowflake, it is encrypted, and you can have full confidence that all that data that sits in Snowflake is encrypted at rest. We also have, it was very important to us to get external validation of that security. So we are PCI and HIPAA available, and we do have a lot of the big institutes certifying us. So there are different instances, different subscription models for Snowflake. HIPAA compliance does come at an extra cost. This is the health compliance in the US. However, we do cater for all those scenarios. So as you can imagine, very successful at Capital One in addressing those challenges that we spoke about. So that Monday morning challenge that they had, and that concurrency challenge of the data scientists impacting performance for their BI analysts no longer exists. They separated, built individual compute clusters for their data science team and their business analysts. There is no more concurrency problems from that regard. Their multi-warehouse, multi-cluster capability makes sure that it peaks and troughs depending on demand. Scaling, their data scientist team is loving this. They are able to scale and put as much data in as they want and get as much compute as they want in bursts of time. The other win that they've had is from an internal billing perspective. So the Snowflake UI, which Saku will show you later, does allow you to separate where the compute's being used. So the data science team now is able to be billed efficiently internally for the compute they use. So this is really helpful in a shared traditional architecture. It's really hard to build which internal department is using the platform. In Snowflake, that's very easy, and it's all managed in the metadata. Now, Capital One's resiliency is very good. They have actually built failover from the US West region to the East. So I talked about that availability zone failover. Well, they've gone a step above that, and actually Snowflake's helped them build resiliency across AWS regions. So in the case of a catastrophic failure in California, in the US West, Capital One is also deploying their data in the US East region. So they'll fail over to that region. So that just ensures they're 100% available, even in the most horrifying of circumstances. Security, obviously, peace of mind. They're a financial institution, all their data being encrypted. They're very happy that that all comes out of the box and they don't have to do any additional work. So that's worked quite well for them. Obviously, we're having extreme growth at the moment. We've got all sorts of customers that are now on the platform. We've talked about Capital One there, Adobe, lots of gaming companies like Double Down, technology, music companies like Sony, Kraft Foods. So we do have a broad variety of customers that are currently on the platform. So it's a very exciting time. There was one more function that I just wanted to briefly discuss, and that is data sharing. This is a relatively new functionality that's been brought out at the end of last year. So a data provider, a lot of the companies we work with are data providers, so they consume data from their clients and then want to share that data either back with the clients themselves or potentially with third parties. So the concept of data sharing is about making that process easier. It is very hard passing files back and forth between clients. So what data sharing is all about is about creating a secure data share. So you might have an example where you're bringing in 5 different data providers, bringing in 5 different sets of data, and they're doing some aggregations on top of that to provide value. They can create a data share and share that data live instantly. So what that means is they can, either a consumer can create their own Snowflake account, or the data provider can create them a read-only account so that they can access that data. Then they will spin up, they will have a virtual cluster themselves, so there's no contention. They're not jumping onto your compute clusters. They will have their own virtual warehouse, and then they can, depending on the security that the data provider presents, they can then access that data and run their own queries against that data. And that's instantaneous. So as soon as you click run the SQL to share that data, a consumer can jump on and start running their queries against it. So it's a really powerful use case to promote the sharing of data throughout organizations, something that in the past has been incredibly difficult to do. So the potential reduction in costs and service around FTPing and sharing S3 buckets and duplicate files and data getting out of sync just won't exist in this world. You're all sharing that same data set with no contention between it and with all the security that you would expect. So it's a very interesting use case that's just starting to take off in the US, and we hope it does in Europe as well. So just to reiterate what makes Snowflake different. So we are a data warehouse as a service. So we have very little management, and I do have a slide that illustrates that. But your traditional data warehouses in the cloud have reduced the management, but it's not as a service. There is still manual tasks that you have to undertake. Query services tend to be a bit of a black box, so it's quite hard to understand from administration process how they work. Concurrency, we've talked a lot about that. We are unlimited automatic concurrency scaling, so we really support you getting as much as you can out of that database and pushing us to its limits, and we'll be able to handle it. Some of the traditional ones still struggle with that to implement that service. Flexibility, we haven't talked a lot about it, but Big Data Solutions will demonstrate the support for JSON and semi-structured data sources. So that's a really unique use case that a lot of the other data warehouses don't have out of the box and require you to transform that data. You can drop that data straight into Snowflake and start querying it with a language SQL that you're familiar with. And scaling, as I've talked about, on the fly in minutes. So both functionally, great, you can cover all those use cases, and the cost savings in that can be huge. So I'm just running out of time. I might skip that, but this is just validating all the things you may have heard from other vendors, but we've put a lot of effort in making sure that none of that is inaccurate. It is all true. We are ANSI SQL database. I've done a few migrations myself from Oracle and other platforms and not had to change a line of code. We do support ANSI SQL. It's not a Snowflake version of SQL. It is SQL. So just on that zero management. So I like to say near zero management. You will still need DBAs. Someone needs to create the roles, create the groups. Someone needs to allocate certain people to certain, needs to create the virtual warehouses that I talked about before. So it's near zero management. So to give you a bit of an example of how far we've come from the on-premise world to the Snowflake world, just going through a couple of those. Infrastructure used to be managed by the client. Obviously, the Redshifts and the cloud-hosted EDWs have taken a lot of that infrastructure pain away, but we've gone to that next level and incorporated scaling of that infrastructure in there as well. No vacuuming of tables, no indexes, all of that management goes away with Snowflake. That all happens under the hood, all by the vendor. So your DBAs can get into the tasks that are more important. They don't have to do those menial tasks. You won't be updating statistics or any of those tasks that you may have had to do in the past. And then we talk about security and data service. Features like undropping tables. So we've all been in that case where someone accidentally truncated a table or accidentally dropped a table. Well, features that like the undrop functionality in Snowflake make all that data service and security and resilience out of the box work really well without any heavy lifting from the client themselves. So I'll just move quickly through this one. What are some of our customers doing with Snowflake? So a lot of clients still are creating data marts and extracts of data for BI tools to ensure that they get the performance. Some BI tools only integrate with certain platforms. So we find a use case to replace that and consolidate that all in Snowflake is very popular. We have integration with a lot of BI applications and all the big BI tools. So that in some cases, clients have removed their need for data marts altogether because you get that performance and you can scale independently. They're hitting the raw data with their BI reporting. Obviously, replacing the data warehouse with Snowflake to deliver that scale, deliver those scale for data volumes is very common. So what's come up in the last couple of years as well is the concept of a data lake and staging areas. A lot of clients are doing that in Hadoop today. Some of them with use cases that aren't too complex have been able to replace their NoSQL data lakes and push that data straight into Snowflake. So really simplifying their architecture, all comes delivered to them by the platform. So massive cost reductions and technical complexity is driven down. So there are plenty of customers that have found use cases to replace all of those existing technology patterns and put Snowflake at the center of that. And this slide really demonstrates what that would look like. So that is having Snowflake at the center, covering those logical data marts, covering the EDW and the data lake ingestion from S3. We're not an ETL or an ELT tool. We do integrate with third-party platforms like Talend and Matillion to perform those functions. So they would still sit outside the Snowflake platform. But you can see that we are in there and replacing a lot of those technologies as the platform of choice. Now, I just wanted to touch briefly on Azure as well. We are currently a cloud platform that exists within AWS. We are in the beta testing stages for Azure. So some of the principles that we've made sure that we're going to meet in Azure, we want the same set of features that you get within the Snowflake platform in Azure. Added support in the SQL service to integrate with Azure, so we're working very closely with Microsoft on that. There will be a process whereby features are available on AWS first and then will be released to Azure afterwards. We are looking to try and gain price performance parity when compared to AWS in Azure. The architecture, as you can imagine, is very similar, just using the services in Azure to deliver the same platform. Obviously using their Azure Compute as the virtual warehouses, and the underlying table structures will be sitting in Azure Blob Store as opposed to S3 Blob Store. So as I said, we're currently in beta testing. I will try to get some more firm dates on that. That will be released in the US first, and then we'll port over to Europe shortly after. So thank you very much for your time. I will now pass back over to Ossi to continue.
Yeah, thanks, Anthony. Before we continue to the demo phase, a few questions to you, Anthony. So, where do you see the biggest growth in interest towards Snowflake coming from today?
It's now coming from the enterprise customers. I think there was a slow uptake in the cloud initially because of some of those concerns I mentioned. So we're getting a lot of the financial institutions that have just sunk a lot of money into on-premise solutions that want to adopt the cloud and everything the cloud has to deliver. The second one would probably be some of the people implementing Hadoop when they didn't need, or I'm going to say big data platforms that they probably didn't need based on their use cases, and just had a very large bill come about from that. So they've found that Snowflake can cover a lot of the use cases that they had.
Okay. And on average, what's a typical new customer? So how they engage with you during the beginning?
So from a practical point of view, they'll typically have some data. They'll already be in AWS. We do work with some who are coming straight from on-prem, but typically they're in AWS. They'll run a short POC and they'll have some challenges with Redshift or with another platform, for instance, whether that be performance or concurrency. We'll take those problems, push them into Snowflake, a quick POC that we can generally have up and running in a week or 2 weeks, prove that we're a solution to those problems, and then on top of that, we can move into production and start bringing in some of the other functionalities that maybe they weren't aware of.
Okay. So Anthony, thank you. And I will keep you unmuted, so if you want to add something during the demo section, so please do so.
Thank you.
So I will now make Ossi the presenter. So Ossi, off you go, I guess.
Yeah, thank you, Saku and Anthony. Hold on a second. Can you see my screen? Okay. My name is Ossi Manninen, and I'm working as a consultant at Big Data Solutions. I've been working here since last November, but I've been involved with BI tools and ETL tools since roughly 7 years now. I'll be walking you through the web interface of Snowflake, and then we will do a demo where we consume JSON data from my laptop. We'll upload it to Snowflake. We first create a database structure, then we take a look at this SnowSQL command line interface tool. Then we do some querying to JSON data, and finally we create this kind of, well, tiny data model. Okay, I'll jump into the web interface now. Yeah, so basically when you log into Snowflake, you get this view from all the warehouses that you have set up there. But let's start with the databases, because there are these 4 different sections up here. And at least in my opinion, it's more logical to start with the databases. So here you get a view of all the existing databases, and you get to create, clone, drop, or take ownership, well, transfer ownership to another user if that is needed. Take a look at the create button first. Here you can simply create a database like test1. And actually, there's this button for almost all things you do in Snowflake UI. You get the chance to see what the SQL for that command is. So this basically comes in handy when you make a list of things that you've done, and you can easily recreate those steps afterwards because you have the SQL in hand. Or you can create it now. And then there's the clone button. What this does, it actually creates a zero copy clone, which means that the clone will not reserve any additional hard drive space. It's fully writable, but it's independent of its source. So the changes made to the source or clone are not reflected in the other object. maybe use case for this would be if you need a development database, so you could clone the production database and do what you will with it, and then create a new clone when you need a fresh data. And there's the drop. Actually, we can use that for the test that I just created. And you can also check SQL from here or run it directly. And transfer of ownership is if you need to transfer the ownership of the database to another role. Snowflake is role-based, so when you create users, you actually give access to things, to these objects through roles. So you should always assign the appropriate roles to users, because roles get the access rights to objects. We can take a look what's in a database. So basically, when you dive into the database, we're now at demo DB. You get these different sort of views to what you can configure inside the database. So there's of course the tables. You can create a table from here. Views. There are some system views automatically always created. Then there are schemas. These are automatically created as well. And then there's the stage area. And also file formats and sequences. Well, I'll talk about the file format a bit more later. Basically, when you create a table, you get this kind of window. You give it a name, and you have to add one column as well. And you can see the SQL for this as well. Let's not create that now. And you also put it in a schema. But during the demo, we'll be creating a database schema and a stage area and a few views. So you'll get a closer look at them then. And we could jump into the warehouses. This is the compute part of Snowflake. So basically, when you create databases and other objects in here, that actually doesn't consume any of your credits. So it's cost-free to create tables and databases and views and so forth. But the minute you need to use a warehouse, which is compute, then you get to consume the credits as well. Again, these are pretty simple. This how you create a new warehouse. You give it a name, then you determine the size for it. Snowflake uses these nice kind of t-shirt sizes to describe the warehouse sizes. Actually, the extra small, when it consumes 1 credit per hour, that means that there's one server running in extra small and 2 servers and 4 servers and so forth. And you can actually set auto suspend, which is a nice feature, that the warehouse goes to suspend mode after X amount of minutes after queries have stopped. So you won't consume any more credits. If I would have a enterprise edition of Snowflake, we would see this it's called multiple clusters. So we could actually spin up the same kind of cluster if the queries start to queue up, and when the queues are disappeared, we could spin it down again. And then there's this auto resume option as well, which means that you don't have to manually spin the warehouse up when queries start to come in again. So you can automatically spin it down and automatically spin it up when it's needed. And again, you can get the SQL from this zip. And if you need to afterwards go to configure it again, you can actually set resize the warehouse from here as well, and change these other settings here. But you cannot rename the warehouse. You have to create a new one if you need another name for it. Then there's a suspend button, which is in use, of course, when the warehouse is up, and you can spin it down by pressing suspend. Then you can drop a warehouse and again transfer ownership to another role. The next one would be the worksheet, and this is where the magic happens, basically. This is the query window here, so you can actually write and execute queries here. You can start executing one for now. And this is the window where you can see that it's executing, and you get this kind of statistics of the execution. And actually, you can even see the SQL code from here as well. And you can copy and paste it if there's a need for that. The window here, where you can see this, there it is. Yeah, here you get the results from the query. And then in this query window, there are options right above them here. You can actually select which role you want to use when you're executing this query. There's also a place to select which warehouse you want to use for this query. Of course, you see only the options that are available for your user that you are using when you're logged in here. So I happen to have all the rights, so I can even see the account admin here. Here you can select the database, and this is selecting the schema. You don't necessarily have to select all of these here, so you could tell it in the SQL code as well, but this is just a good thing to know that the option is here, because you might be logged in using as I am here as sysadmin, and I change my role to account admin. Now, if I execute something in the SQL window, I'm still executing it as sysadmin role. Okay, and then there are these worksheets that you can create. You can actually abort or running queries on the current worksheet that you have opened by closing this, or this is another option from here. And actually you can resize a warehouse from here as well. And there's an option to load the script from your hard drive as well. You can create different worksheets as I have here, and you can save them under your user's profile, or you can delete and close them as well. I think there was some kind of restriction how many of these you can have open at a time, but that's not really a problem, because you can close them as you don't need them. Okay, let's jump to the next section, which is history. Here you can see all the queries that have been executed. So there's a big list of things, and Of course, you can only see the queries that your role entitles you to see, so you won't be seeing all queries if you have some kind of low-level access to these, to Snowflake. And there are filters you can use to find things from this, so forth. Then there's the count window. Unfortunately, I can't show you the billing and usage page because there's some information that I cannot show you. But I can show you these other options here. Here you can create users. Actually, we could create a user for the demo purposes now. I use this guy always. Because he gets the job done. Move that. And I'll give it a default role as sysadmin, so we can get all the necessary steps on the demo done with this guy. And there it pops up. And you can see that his role is now sysadmin. There's a page for roles. You can actually create your own roles and give them properties of the system created roles. So you could create a role here and set what the parent role of it is. We won't do that now. And there's this policies window. This is actually for network policy. I haven't tried this, but it looks fairly simple. You can enter which IP addresses are allowed to connect here and which are blocked. Here's user sessions. So that's pretty self-explanatory. And then there's the resource monitor. You can actually set quotas for accounts or by warehouse. So I could set a credit quota for a specific warehouse, and then suspend it when the credits are used, and so forth. So this is a way to manage the cost as well. Yeah, I guess I'll jump into the demo now. I've actually prepared all of the SQL commands that I will be using in this demo, but I'll show you the. Hold on a minute. There we are. Oh, one thing I forgot to mention about there's this help button as well. This is very useful. You can access the Snowflake documentation, which is accessible even if you don't have the Snowflake account yet. So you can go to this address and check out the documentation. It's very good. There are videos how to do things and detailed instructions how to do all sorts of things. There's also the support portal. We won't go into that now. And then there's the download section where you can there it is. Yeah. Here you can download the command line interface for your platform, and then there's the JDBC driver, ODBC driver and so forth. I will be actually using this command line interface, SnowSQL, during this demo. But if you want to connect to Snowflake using a sort of a third-party database browser, like for instance, I have this DB where you can use the JDBC driver to access the Snowflake. I have this Snowflake instance open here, but you can download it from here. There's a link to the main repository. So let's get on with the demo. I'll just copy this first here, and then I'll show you a slide what we're gonna do here. First, we'll create this metadata layer, which and all of this in the metadata layer actually doesn't involve using the virtual warehouse. So there are no credits built when you do these kind of database maintenance jobs. And then we start by creating user, and that's the thing we just did. Then we'll create a database. We'll create a schema under it. We'll create a stage area where we'll upload the JSON file. Then we'll create a landing table which will be used for the data within the JSON file. So we will move the data from the file to this landing table. And to do that, we have to have this file format created for the landing table. So Snowflake knows how to parse the JSON data when it comes in. And finally, we'll create a virtual warehouse that we can use to query the data. Yeah. Okay. First, we'll start by creating a database. There we go. Now we can see the database here. So if we dive into it, we don't see any tables or views, but these are the system created views. There are no schemas, user created schemas yet, and there are no stages or file formats either. We jump back into the worksheet. We'll create the schema. Now we have a schema here, data. Then we'll create a stage. And this is the place where we will upload the JSON file layer. Now we should have a stage table. There it is. And you could actually create it from here as well. But, and this, what we just did was internal Snowflake stage. We could use an S3 bucket for a stage as well. And if we would do that, we would have to select this and then have a link here that would point to the S3 bucket. So if you're using already S3, you don't have to sort of double the JSON data in two places. You can use directly the S3 bucket. But for the purposes of this demo, we don't have an S3 bucket, so we created an internal stage for Snowflake. Okay, next I'll create a sort of landing table for the JSON data. So this table will be used to transfer the JSON data to rows from the file that will be located on the stage. Now we will create this file format so Snowflake knows how to parse the data that's coming in from the stage. I'll create this first and then we'll take a look at it. This is the one we just created. So basically, I'll better do it like this so you can see. So here you can set what kind of data you're expecting to come in. So it can be a CSV, JSON, XML, Avro, or Parquet. And you basically define how do you want to compress it once it hits Snowflake. And then there's the column separators and so forth. So if there are any special characteristics on the file that's coming in, you have to define them here. And when you start loading the data, then you refer to this file format configuration that we created. Yes, and next we will create a virtual warehouse. We can check. Yeah, there it is. Now we're ready to bring the data in because we have the database structure in place. We have the stage where we can upload the data. So now I will open the SnowSQL. Actually, I have pre-installed it, so I don't have to download it now from the help section and install it. So I can just utilize it from my command prompt now. There you can see the SnowSQL application, and we'll be connecting to our Snowflake instance with the user JBauer. Yeah. Then we'll connect to database. And it was World Bank. Schema. And the schema created was called data. And we'll be using warehouse. And it was World Bank queries. There it is. Yeah. And now we use this put command, which actually doesn't work from this web interface. So if you are using this command, you have to use the command line interface. There. Now we have uploaded the JSON file. That was the name of the file on my computer, and now it has compressed it to Snowflake. We can actually see that it's here now using this list. The list at can see that the file is now in Snowflake. So we cannot query the file just yet because it's just staged on the Snowflake. So we have to pull out the JSON rows to a table. And the next step is to copy the stage data to a table. And here I will run this command. As you can see, there's a copy into World Bank source from the stage table. And here we are using the file format. So Snowflake knows how to parse the data. There. Now we can see that 500 rows were parsed and put in the table. We can go check out what the table looks like now. One thing I forgot to mention, that when we created the table here, we can check out, it has only one column at the moment. I named it full row, and the type of it is variant. So the variant type in Snowflake is used for all this kind of unstructured data, like JSON. So that's where we brought all the data now. And now we can see how it looks on the variant column. There it is. And this, as you can see, it's not very readable yet. You can actually, if you click it, you can see what's inside there. But the thing is that once you have it brought to this stage, you can actually start querying with this normal ANSI language with some Snowflake extensions. So I can show you this one query here. So this actually, as you can see, we're selecting from full row, which is this column over here, and then we'll diving into country code, and we can actually see it here, this. And the next part is country short name, which is this, and then finally country name. So we're pulling these out of here. And there, that looks like a database. Okay, now we could, because we are doing this sort of small data model, let's put this into a view called dimension country view. Right, and now we can query the view with normal SQL. There it is. Now, because it's in a view, it's actually the view is querying the JSON data from the variant column. Okay, we have another dimension data here, which pulls out major sector code and major sector from those JSONs. And we'll put it into a dimension view as well. And now we can check what the view looks like. There it is, yeah. So we can pop into here and check. We can see the views here. There's the major sector view, and then country view. Okay. Then we have this query that makes a sort of a fact for the purposes of this demo. So this and all. yeah, we have this sort of fact table, and we can put it into a view as well. And what you can see in this query, we have this lateral flatten function used, which is actually a way to sort of dive into arrays. Just a moment, I'll show you an example. So we have this major name code selected to this particular lateral flatten. So let's see where it is. There it is. So we're using this lateral flatten to pull the rows from the array using. Oh, actually I haven't used that one. Let's take another major percent. Yeah, it's in this calculation. Well, I'm not sure if this is a clear example how this is used. But in any case, the lateral flatten is a way to bring all of these arrays into rows, which is quite nice. Because as you know, JSONs often contain these arrays. But it's actually fairly simple. Did I create the view already? Yeah, there it is. Okay, and actually that's pretty much the demo that I have, and Tapani has some reports that are diving into these dimensions and the fact. But as you can see, once you get the JSON in the Snowflake, it's fairly simple to start querying the data from it.
Okay, thanks, Ossi. While we are transferring the presenter rights to Tapani, so one question to you, Ossi. So you'll be experimenting Snowflake now maybe a bit more than a month, maybe almost 2 months. So you'll be dealing with customer structured data and JSON data. So how has it felt, and what has been sort of the ways learning?
The right word would be it's fun because it removes all the usual problems that you experience with JSON data. You can just query it. It's really simple once you get the JSON. Once you understand what's within the JSON, but.
And has it been so that you've basically been using the Snowflake help
yes.
button and the documentation and introductions that existing?
Yeah, I've been pretty much with Tapani. We've been learning this together, and it hasn't been all that difficult. It's very good. Okay,
over to you, Tapin. I guess you have the presenter rights now, and I guess we can see your screen also.
Yeah, so good afternoon. I'm Tapani Deci. I'm a consultant at Big Data Solutions like Ossi. And what I'm gonna do today is basically, as you can see on my screen, this is the data brought through the view that Ossi generated before into Burst Professional, which we'll be using to visualize the data. So here you can see basically the 2-dimension views and their data. Once it loads, here we go. And this is the online version, so there might be some small loading times. Yeah. So once you brought the data in, you basically publish it, and Burst Professional offers a way to basically really quickly model the data. So what we have done here is made a few joins to the data, so we can pull the key values based on the codes, which are the surrogate keys for the dimension and the fact table. So there we go. This is the really simple model. And next up is basically to show you the reports we've generated, which are actually here. So basic visualizations, not that much data to work with. So there's just the same diagram shown in a couple of different ways. You can see the values split up based on the total amount spent by the major sectors of industry and the country names. And yeah.
And you connected using the JDBC driver.
Yeah, basically you can connect basically anything to Snowflake that has a JDBC connector. Might it be your custom database development tool or a visualizer tool. We ourselves have used several different visualization tools already, and all of them have worked without any major problems. Basically, it's mainly dependent on the software's functionality itself more than the actual, because it's a JDBC connector. It doesn't bring anything, how would you say, special into the mix. And of course, all communication are actually encrypted via the Snowflake's JDBC adapter, so you don't have to worry about encryption. And yeah, we can actually even see on the Snowflake side what the visualizer tool has done. So here, basically, the user that I've been using with that visualization tool is Snowflake Webinar, and it uses a dedicated warehouse for queries. And here you can see the whole history, which this actual user has queried the database. So as the Burst Professional created its model, these are the queries it generated to the warehouse.
And by clicking one of those queries, you can actually copy that.
Yeah, we can actually replicate the query in Snowflake quite easily. Which, oh, well, maybe not this one actually. Let's go back. Maybe a select statement might be better. Yeah, you can see the query here, and of course, it's actually doing some, there we go. Yeah, here you can see actually the Snowflake security functionality. I didn't try this previously, but it's only available for that specific user that made the query. So because I'm using a system admin user here, I can see that a specific user has queried the database, but I'm unable to see the actual response he got from the database itself. So happy accident.
Yeah, well planned demo.
But anyway, what we were about to show, if you click here, you can basically replicate the query, and it generates basically a view like this. It's just the same interface that also used to create create the models themselves. So basically, that's my part. Yeah.
Okay, thanks, Tapani. So basically, we are running out of time. It seems that we have received a few questions, but I guess we will reply to those questions afterwards. So the webinar has been recorded. It will be available shortly through our website, Big Data Solutions at FI, and we most likely will gather those questions and answers attached to that page. So thanks for attending this webinar. We hope that you got some details and intro to Snowflake, and obviously if you want to learn more, please contact us. Thank you.
Thank you.
Thank you.
Thank you.